So we want to talk about the Sobel edge detector. As the name suggests, it tries to detect edges in an image, and the main idea is to look for gradients in the image because think about an edge, it's a rapid change in intensity of brightness. So we want to look for those areas in the image where there is a rapid change in intensity. It can be vertical, it can be horizontal, it can be in any degree. So in order to detect this, you want to get the intensity change in the x and y direction. Using those two x and y, you can get combining them any direction you want. So you can find an edge in any direction you want, but we will look for gradients in the x and y direction. This g horizontal, as you can see, it tried to detect gradients along the horizontal plane, namely it will find vertical edges because we try to see if to the right of the edge and to the left there is a very high change in intensity, and it will tell us that if there is very high change in intensity, there is probably an edge. This kernel, let's call it, will be the G horizontal of the central pixel. We will also try to see if there is a horizontal edge. We will see if there is high intensity change between the two sides of the horizontal edge using the G vertical here. So after we did this, the central pixel, we have two values, the G horizontal and G vertical. We want to know, summing that all, what is the power that there is in this exact pixel edge. So we will calculate the magnitude from both G horizontal and G vertical. We'll do it like this. G equals like a Pythagoras theorem. This is the gradient magnitude in the pixel, and we do it for each pixel. So each pixel we get will get gradient magnitude, how much there is a change. Also, we can calculate the vector angle, namely what is the direction of the edge using the gradient direction, gy divided by gx. Um, okay. So what's the process? The process is we start usually with an original colored image, but we don't really need a color. It's three channels RGB that we don't really need because if in a grayscale there is an edge, usually also in the original image, colored image, there is an edge. And with grayscale, it's much easier to work because there is only one channel, one brightness that changes and not three. So let's move from original to grayscale. And then after this, we can start by doing a blurring effect, for example Gaussian blur, in order to take away all the noise. Remember that we are very sensitive to high intensity changes. This is exactly what we are calculating. But noise can also create very high intensity changes in very random places that are not edges. For example, if there is a point, if there is something that was noise in the image, those little things cause very rapid changes, and we might consider them as edges. We want to detect them as edges, and we really don't want. So let's do Gaussian blur before we start to apply the kernels. And after this, we can apply the gx, the gy, the kernel that we talk about, calculate the magnitude, and then the angle. This is the convolution part, the applying of the kernels. And then we are getting the edges, as you can see, of the image. This is, for example, you have uh, you have some drawings going on, and we can see the edges, of course. This is the idea of finding the image, the edges in the image. So there are many applications for this, but this is it. This is the Sobel edge detector, and thank you very much.